All right, thank you, Reddit user Hintern314 for this question. I think this one came from this came from Ask Math. So this question gives us a bunch of limits as x approaches infinity, x approaches some value, and it tells you what the limit is. And then the idea is that you should sketch a function that meets that criteria. Okay, I misread that. It should sketch all of the it should meet all of the criteria below. So let's read. So the function needs to be continuous at all points. That is not listed. Okay, and then there's some instructions on how to submit it. You must include a complete labeled graph with the letters A through K to receive credit. Okay. This is obnoxious. I don't like this problem at all, so hopefully I'll be able to help Hintern out here. So we're going to have to toggle back and forth between these screens to get this right, but let's look at a couple of things here. When x goes to positive infinity, we need to limit out to -3. And then I think that is the only infinity that we're going to deal with. Oh no, here we go. Negative infinity, it's going to limit out to -2. Okay. This doesn't actually have to be a real function, so we don't need to like write a closed form version of this. But then we have a couple of values. We have -4. Doesn't tell you positive or negative, so at both sides the limit should be equal to 8. And then -1 from the left, it should be equal to 4. And the -1 from the right, it should be equal to -2. And then the function definition at -1 should be equal to 0. Okay, so here we have limit from the left, limit from the right, and a different definition. Okay, and then so as the limit approaches 3 from the left, we should go to infinity, and as the limit approaches 3 from the right, we should go to negative infinity, so we want some divergence happening. And then as x approaches 9 from the left, we want to go to 5, and 9 from the positive, we want to go to 1, and the definition at f of 9 is 5. Okay, so we have some obnoxious stuff going on. Our highest y value here is 8, and our lowest y value, well, I should say it's positive infinity, but the highest one we need to label is 8. And then our lowest is -2, so we can think of that as our scale. Should be like -5 to 10 or something like that. And then our smallest x value is -1. The same thing, coming from negative infinity. So we can do like -5 to 15 or something like that. All right, let's draw a graph. Oops, don't look at that, guys. Okay, here we go. And I got these handy dandy rulers with Autodesk. This is Sketchbook. It's great, I love it. Okay, there's that. And then we'll come over here and do another one. Okay, so when you do these properly, you have to put the little arrows, and you have to label your axes. And so, okay, where are we here? So when we go towards positive infinity, we want it to be -3. So let's say -1, -2, -3, -4, -5, -6, and this is not perfectly to scale. You're gonna do a much neater, better job than drawing than I would. Okay, something like this. Okay, so as we go to infinity, we're gonna come out here to this -3 range, and then For negative infinity, we need to go to positive 2. So let's do the same thing. 1, 2, 3, 4, 6, 7, 8, 9, 10. That's probably good. So 5, 6, 8, 10. You can fill them in as close as you want. And then let's do the same thing. So let's go 2, 4, 6, 8, 10. Ugh, that's gross. Okay, so -2, -4, -6, 12, and to the right. Okay. So let's get a couple of these function definitions locked in here. So we know f of -1 equals 0. So when x equals -1, which is right here, f of x equals 0. So f of -1 is 0. And then we also know that, where does it say? F of 9 equals 5. So f of 9 equals 5, somewhere in here. Okay. Then we have the limit as x approaches -4 is equal to 8. So -4, and then we'll come up. And so for the limit to exist, that means that the limit has to be the same as the function definition, right? Well, that's not true. For continuity, you need that. So this is saying that it exists, but we actually don't necessarily have to have it exist. So let's put an open circle. And then boom, 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 some -1 from the left goes to 4. So here's 4, so I'll do an open circle here. And so something should be coming into that. And then -1 from the right goes to -2. So that's going to be somewhere right here, and something goes in. Oh, wait, sorry. Right here. So something goes into that from the right. And then f of -1 equals 0. Then we've got, so x approaches 3 from the left. So 3 from the left. Here's 3. And as x approaches this, it wants to go to infinity. So we should have a vertical asymptote here. Okay, and I could probably have drawn that with a ruler, but. And then conversely, when we approach 3 from the left, we want it to go to -infinity. So it's going to have another asymptote here. Let's see where that levels off to. And as we approach 9 from the left, we go to 5. So 9 from the left. So here's 9 from the left, so it should be somewhere around here. And then 9 from the right goes to 1. So 9 from the right goes to 1. And these are both over x equals 9. And then f of 9 equals, oh, I wrote my 4 like a 5, or like a 9, so this is actually, this is the 0.95 here. It's the 0.95. So this is defined here. And when we go to positive infinity, we're -3. So we can draw something like this limiting off, oh God, I'm sorry, this is terrible artistry. This is gonna approach -3 somewhere out here. And then this is going to approach 1. We've got the asymptote here. We've got this approaching -2 from the right, and then approaching 4 from the left. And then -4 goes to 8. So it doesn't say that it's defined there, so we'll just leave it an open circle. But since it has to approach it from both directions, we need it to go there from the left as well. It doesn't necessarily have to be defined though. And then to the left we get negative infinity. So, and since we can take, or we get -3, so actually 2. Since we can take some poetic license here, since it doesn't have to be a real function, this can look like that maybe. So something like that. And this is supposed to be limiting, like there should be an asymptote here for 2. So I'm going to draw that more beautifully. So if that's 2, it's going to go something like, no. This drawing meets all of those requirements, and it's continuous everywhere it doesn't say it. So let's actually make this continuous here. That's filled in, and that meets everything that they said. I hope that helps. I mean, interpreting that may seem a lot harder than it actually was once you see what I did, but you know, you're just like looking at all of those conditions and trying to make a piecewise function that meets them. And if you have a really good understanding of what is a definition of a limit from the left and from the right, and when the limit actually exists, it has to be the same from the left or right. And you know what they're talking about going to infinities. As you approach infinity in either direction, it goes to some value, or as you approach a value, it goes to either of the infinities, right? So that's an asymptote. Yeah, this is kind of rambling, but you know that's it. And it's not any harder than that. If you have any questions, hit me back in the comments.